Assalamualaikum warahmatullahi wabarakatuh. Okay, today we from group D from Bmma S12. We are gonna present about our assignment on vehicle dynamic. So we got the topic on vehicle tires. So next slide. So introduction. What is vehicle tire? So as we look at in deep, tire is a ring-shaped components that surround a wheel rim to transfer the vehicle load from the axle through the wheel to the ground and provide flexibility cushion that absorb the shock. It also provides a contact patch that is designed to match the weight of the vehicle. The material of modern pneumatic tires are synthetic rubber and others technology that have been made. So the tread provides traction while the body provides containment for the quality compressed air. So next slide, we will be looking on the literature review for summary. So as we look at the table here, this is our literature summary on vehicle tires. So we got into a few journal on Google Scholar or any sources. So mostly we got from Google Scholar. So the first one, we got an article from IOP Science, and the others are from the journal. So without further ado, we will continue this presentation with our discussion on the journal. So for journal 1, I will be discuss journal 1. I, Muhammad Arif Lukman, will discuss about displacement of a free tire in natural frequency to determine noise. So we will be going into the methodology. So the first methodology we got is we use an stationary and moving equation to explain the characteristic of elastic tire. So based on the equation we get, we detect some wave propagated by structure, vibration, and oscillated around the tire circumference, and produce a natural frequency in radial direction changed by the difference wave number and the displacement structure in the tires. So the wave propagation in the tire structure vibration is the one of the generated noise. So the second methodology I get with model a thread 2D circle rubber band. So we'll be going into the simulation on this. So as shown on the figure 6, we got the first pair of vibration AB propagated diagonally wave in Y and X axis. The second pair CD and the third EF pair indicated oscillation wave that generated by the displacement radially and laterally around the side wall. So based on that variety of propagation wave, a different point of extreme displacement can be produced for all wave number. So the third one, vibration theory. So the tire can be considered as a toroidal shape with double curved surfaces in steel bladed radial tires such as a passenger tire. However, the thread band forms a relatively rigid flat band whose largest principal curvature lies in the plane of the wheel. So the tire usually categorized as bias and radial. In certain frequency range, the tire behave like a spring mass system. So the vibration theory explains about observe the tire behavior when it move on a bump. So the last one of methodology, we find that finite element analysis. From that we can analyze the tire characteristic, the frequency of the tire, natural frequency. So we're going on the result. the natural frequency, flexural wave propagation in the tire. So on table 2 and 3 we have table 2 we have a thread band behavior, and table 3 we have a side wall behavior. So from this one we can conclude that natural frequency generated by a normal tire is 48 to 658 Hz. Table 3 represent about the number and the displacement behavior of the natural frequency. So in case of large deflection on the tire sidewall, it can be destroyed and initiate sidewall crack when it's this deflection generated during tire application in a range of this frequency. So next result, I got the vibration of the tire. The vibration of the shell passenger car tire are a combination of several different wave type. It appears at different frequency, so it can be traced the formation of various type of wave which will propagate it and generate sound. So the vibration is also I found in this this researcher found in this journal of his research. So the last one is type of tire structure. So the variety shape of side of mesh describe the type of the tire structure composite. The mesh size of the cross section is smaller than the shell models. It means that composite constructed to support more axial than lateral radial loads, so that the tire will be more stronger and not easily flat. Okay, that's all from me. Thank you. Next presenter.
My name is AMIR, and I will present my general study. So the title that I have studied is the study on the influence of different tire cord structure on tire grounding characteristics, taken from Journal of Engineer Fiber and Fabrics, published in October 2022. So the methodology is tire material property test, establishment of tire finite element model, test and simulation analysis of tire grounding mechanical characteristic. And the result is that every part and material of the tire will experience different tension, tensile strength, elongation, and adhesion force. Tire perimeter differentiated by the bundle, wire diameter, bundle angle, and carcass ply affecting the tire sinking. The tire model stored strain energy is obtained and 3.3% difference according to the cord layer. The methodology is first is the tire material property test. The rubber material is tested by using the uniaxial tensile test of each part of the 225/60 R1800H radial tire. So the rubber is processed into dumbbell shape according to the GB/T 528. Tensile tests were performed in thread rubber, side rubber, triangle rubber, inner lining rubber, and child mouth rubber, body rubber, crown band rubber, back layer rubber, wing rubber, and bead rubber. And the skeleton material was supposed to fill the rubber and cord, including the steel cord and nylon cord. So from that material property test, they were able to construct a graph of the stress over strain and strain curve of a tire material were plotted. By comparison, it is found that the curve distribution of the other compound is a relative concentrate, except for the little large offset of the inner liner. The tire with a different skeletal material parameter were divided into 5 types, T1 until T5. Different parameter of bundle wire, bundle angle, and carcass ply resulting different displacement of tire sinking. The next methodology they use is establishment of tire finite element model. So with the same tire, it is modeled into AutoCAD in 2 dimensions. The section was segments according to the rubber distribution. The skeletal material was embedded into the tire model, and the pressure was realized by applying 0.25 megapascal local pressure inside the tire. And then the tire is fixed and apply a radial force of 8 kilonewton to the ground in reverse to complete the simulation process. The third methodology, the test and simulation analysis of the tire grounding mechanical characteristic. So the tire grounding mechanical characteristic test was carried out by changing the diameter of the belt steel wire T1 and T5, the belt layer angle T1, T3 and T4, number of carcass layer T1 and T2. So the result from the second and third methodology is through that analysis they found that the ground stress of the tire with 5 structural parameter was distributed in 5 areas in asymmetric manner. The bed angle increased from 61 to 63 degree and the tire sinkage increased by 6.6%. However, the angle increased to 67 degree, the sinkage decreased by 1.2%. The increase of apply number, the stored strain energy of the tire decreased by 3.3%. After the inflation, the stored strain energy reached 120 kilojoule, and the stored strain energy under load condition increased by 10 kilojoule. In the same time range, the change of the tire structural parameter did not affect the change trend of stored strain energy. Thank you.
Assalamualaikum. My name is NADZMI Bmma NADZMI. My metric number is B0920101090, and I'll be discussing about the journal 3, which is the title is Tire Pavement Interaction Noise and Reduction Approaches. The methodology for this journal: first, to categorize the noise. The 3 basic elements of noise are source, transmission path, and receiver. When it comes to tire pavement interaction noise, it usually refers to exterior noise including both structure-borne and airborne. For the interior noise, the sound balance or sound quality as shown in figure 18, which is the picture in the figure in the slide, is more of a concern than just making the vehicle quieter. Due to the complexity of human hearing perception, 2 different noise with the same weighted level are not necessarily equally distributed. Then, it can be partly explained by the psychoacoustics, including loudness level, sharpness, fluctuation strength, roughness, and by doing comparison on quiet tire and pavement and their own performance at the same time. Next, the TPIN reduction approaches. The TPIN stands for Tire Pavement Interaction Noise. As traffic noise is expected to be more of an environmental and health concern, the exploration to reduce the noise, especially tire road noise, will be of a greater interest. A lot of attempts have been conducted to reduce the tire pavement interaction noise at the source and to ensure a lasting effect, such as low noise tire and quiet road. The pavement seems to have a greater potential for noise reduction, which is 10 dB compared to the tire 4 dB at the speed of 60 miles per hour. In the following, the approaches to tire pavement noise reductions are introduced. First, the quiet tire comparison. Few of the designs concepts are commercially viable due to the manufacturing complexities and costs, and safety and durability. The sound absorbing material attached inside the tire cavity to reduce the cavity resonant noise. By comparing all the research on tire design, all the way from Iwao and Yamazaki 1996 to Muhammad and Wang 2015, the comparison based on modification done into the tire design. Quiet pavement comparison, there are some suggestions on noise reduction in terms of pavement characteristics, listed parameters such as texture, concrete, joints, and aggregate. As you can see the picture, there is the main sound from the vehicle. The main noise from the vehicle to the loudest is from the vehicle is the total up to 70 dBA. As you can see in this figure, tire is the second most important created noise from the vehicle. For the results, optimizing the tread pattern and tire construction for quiet tires. So in the methodology just now, there's quiet tire comparison. Few of the design concepts are comparably available to the verification, complexity and cost, which is they are trying to make the tread different kind of tread, different type of cavity inside for the tire, and making the tire to create as less noise as possible, and at the same time does not decrease the performance of the tire. In the tire industry, the tread pattern design and pitch sequence optimized have been extensively investigated to spread the spectrum to a broader band, so that the noise will sound less objectionable. Modification for noise might influence other tire performance. However, the tire now has been categorized according to the usage in variety of prices. For the last result of this journal, the pavement industry's attempt to modify the pavement texture for quiet pavement. For the quiet concrete pavement, next generation concrete surface known as NGCS can be the most important. The NGCS is basically made by the conventional diamond grind, which is also known as CDG, followed by the flush grind operation and longitudinal grooving step. It is a consistent, predictable and quiet, non-porous and concrete texture with good lateral stability and hydroplaning resistance. For the quiet asphalt concrete pavement, poroelastic road surface, also known as PERS, can be the most promising. It is varying cost with a very high porosity, greater than 30%, and high proportion of rubber of epoxy, greater than 30% in weight, either in the shape of granules or elongated fiber-like particles. It was claimed that it was 10 dBA quieter than conventional pavement.
Bismillahirrahmanirrahim. My name is ABOKOR. This is our group D, and we are from FTK and Bmma, and here I'm participating with my team is for the vehicle dynamic assessment, and this journal summary of the tire. And I'm going to present here the journal 4, and it's the vehicle analyzing tire strength test. And here there is the methodology and also the results. And for the summary from the journal, for the methodology, we can say that in this research, the methodology describes various tests that we are conducting on 5 different branches of the size 195R14C using calibrated equipment and following international standard. And the test including dimensions test, tensile test, and also Blinger test and internal pressure test. The tests we are carried out of the measure tires dimensions, tensile strengths, and also the methods of the electricity, and also ability to minimum and air high seal and internal pressure residence. And the results of these tests we are used to determine the tire's performance and compare it to the international standard. That's for the metrology. And other things we can say that when it comes for the results, we can say the paper discuss 3 tests performed on different brand of tire, including a dimension test, tensile test, and Blinger test. And the dimension test measured of all deformation tire, the tire diameter and width at a different pressure. Pressures are found. There were very limited changes in the dimension with a range of 1%. The tensile test evaluated the maximum density and found that the maximum tensile stress values for all brand were between 1.30 approximately 3 times the value of the maximum tensile stress. The blockchain test measured the load, displacement, and energy at a break at a different pressures and found that the breaking energy is increasing internal pressure and the relation between the accept for the TH specimen. For the result is when it comes to the results of the tests, we are consistent with other researches and indicated that all brands met the standards for the parametric tires. And this Mebati, and that's all.
For the conclusion, the vehicle tires. With the development of technology, we can assume that our improvement on vehicles in ensuring safety, energy conservation and comfort among us users. However, automotive technology has been actively growing and growing every moment for achieving the objective on the automotive industry. By using the mechanical structure of the car to make it crash characteristic greatly improved by analyzing the impurities and find a way to improve. Vehicle tires using more advanced system and material will eventually replace the current traditional pneumatic. However, it is essential for us to choose a correct tire depending on our usage and environment to ensure safety and comfort. Maybe one of the causes of uncomfortable driving and performance drop was caused by the vehicle tires that caused from the disturbance. In conclusion, the design in tire patterns can help reduce some disturbance from the road and that transferred from the pavement to a vehicle body. Thank you very much.